Welcome, dear dreamer, to another quiet journey through the night sky. Tonight, we ask a simple but timeless question. Why do stars twinkle? It's a mystery you've probably noticed since childhood. Those tiny points of light, shimmering as if alive, dancing in the dark. But behind that soft sparkle lies science, atmosphere, and wonder woven together. Here, we'll drift gently between poetry and physics, between imagination and explanation, so you can fall into a rhythm of calm while learning something new about the cosmos above you. If you're new to this space, I invite you to join our growing circle of stargazers. Your likes help others discover these soothing explorations. Your comments add your voice to this constellation of curious minds. And by subscribing, you ensure you won't miss the next journey through science and sleep. So settle in. Let the day's weight slide from your shoulders. Look up and let the question glow softly within you. Why do stars twinkle? Together, we'll follow that light, slowly, gently, until it leads us deeper into the calm of the night sky. You lie beneath the night sky, and every point of light seems alive. Some glow steady, some flicker, as if the universe itself is breathing softly. This chapter invites you into the mystery, why stars twinkle and planets do not. A first step into stillness, curiosity, and wonder. You find yourself lying on your back, the world beneath you hushed, the sky above you vast. The day has slipped away, carrying with it the noise, the hurry, the ceaseless brightness of sunlight. In its place comes night, cool and tender, drawing a curtain that reveals what the daylight hides. One by one, the stars appear, scattered like drops of silver across a velvet sea. They arrive quietly, yet with a presence so ancient, so enduring, that you cannot help but feel the slow weight of time pressing against your thoughts. You breathe deeply. The air is cooler now, calm against your skin. Around you, the familiar earth rests, trees settling, crickets calling, the soft stir of unseen animals in the dark. Yet above you, the heavens are restless with tiny points of light that flicker and dance. Each star seems alive, as if blinking at you from unimaginable distances. You notice that no two stars shine exactly alike. Some waver as though caught in a gentle wind. Some glimmer with a faint color shift, almost red, almost blue, and some hold steady, patient, and calm. The more you watch, the more you feel there is a mystery in this gentle shimmer. Why do some stars seem to twinkle while others remain firm in their glow? Why do the planets, though so much closer, appear as unwavering lanterns compared to the sparkling of stars? You let these questions rise without hurry, like bubbles in still water, not seeking to grasp them tightly but to follow them with curiosity. Imagine each star as an eye looking back at you, millions of eyes peering across the deep of time and space. Their flicker feels like a slow breath, like the pulse of the cosmos reaching you here, on this small patch of earth. Yet, somewhere deep inside, that the stars themselves are steady. They burn with relentless power, with light so constant it endures across millions of years. Their twinkling, then, must be something that happens not within them but between them and you. Your body relaxes further into the ground as you let your mind drift into this thought. Starlight has traveled so far, across gulfs you can barely imagine, distances so great that numbers begin to lose meaning. Each photon, each tiny particle of light, has been moving, untouched, across interstellar space. There, in the emptiness between stars, nothing bends it, nothing scatters it, nothing makes it dance. For all that distance, its path is perfectly straight, its speed perfectly constant. And yet, as soon as that light reaches Earth, it begins to flicker, to shimmer, to tremble. You close your eyes for a moment and picture the atmosphere above you. Not empty space, but layers of invisible air stretching upward like a vast ocean. Though you cannot see it, the air is alive. It swirls, shifts, ripples with currents of warmth and coolness, like rivers of glass flowing around one another. Just as sunlight on water makes the bottom of a pool ripple with shifting patterns, the starlight above is bent by these restless currents. Each layer of air, with its own temperature and density, acts like a lens, refracting the light slightly, bending it first one way and then another. What reaches your eyes is not a steady beam, but a trembling path. This, you realize, is why stars twinkle. Not because the stars themselves waver, but because your sky, your atmosphere, is alive with motion. You are gazing through a living lens. As you hold this image, your awareness deepens. The twinkling you see tonight is not random. It carries the breath of the planet itself. Every flicker is a reminder of the air around you, its unseen rivers and tides, its warmth rising from Earth, its cool descending from the high night sky. The star's shimmer is the whisper of Earth's atmosphere, made visible to your eyes. You remember how, in childhood, you sang of twinkling stars, wondering what they were, what they meant. Even then, the shimmer was enchanting, an invitation to dream. Now, with this understanding, the magic only grows deeper. Science does not strip away wonder. It softens it, like light passing through mist. Knowledge becomes another form of awe. Your eyes drift from one point of light to another. That one, low near the horizon, flashes fiercely, dancing with red and blue. Another, higher up, seems steadier, only faintly trembling. You learn, slowly, that the difference lies in the thickness of the atmosphere between you and the star. Near the horizon, starlight travels through more air, bending more wildly. Overhead, the path is shorter, the air thinner, the light less disturbed. Even this, you think, adds layers of intimacy to your connection with the sky. Where you look changes what you see, just as your breath changes the rhythm of your body. For a moment, your gaze lingers on a planet. Perhaps Jupiter, large and soft, glowing steadily without shimmer. Unlike the stars, planets are not single points of light. They are disks, small but wide enough that their light, spread across your eye, averages out the atmospheric tremble. Their steadiness feels comforting, a counterbalance to the restlessness of stars. And yet, the stars, with their flicker, carry a kind of vulnerability, a reminder that even light can appear delicate after its endless journey. You let this duality rest in your thoughts. Steadiness and shimmer, planet and star, distance and closeness. Both speak to you, both carry truths of the universe. As you breathe, the rhythm of your body begins to align with the rhythm of the night. The stars continue their quiet dance, the planets their steady glow. You imagine yourself floating, not on the Earth now, but within the great ocean of atmosphere. You are a small observer, looking upward through shifting layers, catching glimpses of the vast beyond. The shimmer becomes almost like music, a soft staccato of light notes scattered across the sky. You wonder about those who came before you, lying on the ground centuries ago, asking the same questions, gazing at the same sky. The twinkling has always been there, a universal sight for anyone who ever tilted their face to the heavens. In ancient times, people may not have known about refraction, about air and density and bending light. Yet they, too, would have felt the sky alive with flickering eyes and woven stories to explain the trembling. In their myths, stars might have been souls speaking, gods watching, fires breathing in rhythm with the earth. It comforts you to think that twinkling is a thread connecting you to all who have looked up in wonder. From children singing lullabies to astronomers charting the heavens, from poets crafting verses to shepherds keeping night watch, all have seen this flicker, all have felt its mystery. Science explains it, but does not end it. The mystery remains in the simple fact that you are here, that light has crossed millions of years to touch your eyes, that the air above you shifts and makes the universe dance. The more you gaze, the more you realize that twinkling is not just a fact of the sky, but a mirror of yourself. You too are steady at your core, yet on the surface you shimmer with change. Your breath rises and falls, your thoughts ripple, your emotions shift like currents of air. Beneath it all is a steady flame, a star within you. The atmosphere of your being, restless and alive, shapes how your inner light shines out to the world. You too twinkle. The night deepens. The air grows cooler. Stars move slowly across the sky, though you do not notice their motion, only their shimmer. You are a witness to something vast, something both fragile and eternal. Every flicker reminds you that you are looking through layers, through distance, through time. Each star is older than your world, older than your species, and yet its light arrives now, meeting your gaze as if chosen for this moment. As you drift deeper into thought, a new curiosity stirs. If the star's shimmer comes from the atmosphere, then what of the light before it reaches Earth? What was its journey across space like? And how long has it been traveling? If the flicker begins only here, what path does the light follow before it meets the moving air? You let the question linger, soft and unresolved, like the shimmer of starlight itself. The starlight you see tonight left its home thousands, even millions of years ago. Across the black ocean of space, the light has traveled straight, untouched. Only when it nears Earth does its path bend and shimmer. This chapter slows down to trace light's long, patient voyage. You lie beneath the sky, your eyes still softened by the shimmer of stars. Yet as you breathe and settle deeper into the quiet of the night, another thought emerges, gentle but insistent. If twinkling begins only when starlight enters the air above you, then what of its path before? How long has it traveled, and what story does it carry in its glow? You allow your imagination to follow a single point of light, a star chosen almost at random. Its twinkle has caught your attention, and so you trace it back, across the veil of atmosphere, into the dark beyond. Somewhere far away in a place unreachable tonight, that light was born. It began in the fierce heart of a star, a place you cannot touch, but can almost feel through thought. Within the core of a star, temperatures soar to millions of degrees. Hydrogen atoms, under crushing pressure, fuse together to become helium. This process, called nuclear fusion, releases unimaginable amounts of energy. From that energy, light is born. Not beams, not yet rays, but tiny quanta particles of light called photons. They emerge as if from a furnace, countless in number, filling the star's core with brilliance. But for this single photon, the one you are following, the journey begins not outward into space, but inward into struggle. Inside the dense star, it cannot move freely. Instead of racing directly toward freedom, it ricochets endlessly, scattering, colliding with particles, bouncing like a traveler lost in a maze. In some stars, this inner journey can take thousands, even millions of years. The photon's life is patient. It is delayed and deflected again and again. And yet, eventually, it emerges from the star's surface. At that moment, its path changes. The obstacles fall away. What was once a labyrinth becomes an open road. Now the photon can travel straight, at a speed so constant, so absolute, that no force in the universe can make it go faster. It becomes part of a beam of starlight, radiating outward in every direction. Some of that light travels away forever, spilling into the void. But a tiny fraction sets out toward Earth, though the star has no intention, no plan. The light simply goes, and after millions of years, you happen to be in its path. You hold on to this image, a star so far away that the light it gave off long before your world even existed is only now arriving. If the star is 1,000 light-years distant, then the photon began its journey 1,000 years ago. If 10,000, then 10,000 years. If millions, then its voyage has been longer than all of human history. And yet, tonight, here it is, finishing its journey by meeting your gaze. There is something humbling in this realization. You are not merely looking at stars. You are looking at ancient messages, silent travelers that have crossed time itself to reach you. When you gaze upward, you see the past, the way stars were, not the way they are now. Some may have already burned out, collapsed into silence, their fire extinguished. Yet their light, still on the way, continues to arrive, as if whispering from memory. You let your thoughts drift with this idea of distance and time. The nearest star beyond the Sun, Proxima Centauri, lies a little more than 4 light-years away. Its light began when your world was 4 years younger. Farther stars, in distant clusters or galaxies, send light that began long before your ancestors spoke their first words. The Andromeda Galaxy, our nearest galactic neighbor, shines with light that began 2.5 million years ago. When its photons set out, the first humans were just beginning to stand upright. Now, those same photons reach you, carrying their quiet record of the past. You feel a connection to deep time, stretched and woven through light. The stars above you are not just ornaments scattered in the dark. They are storytellers, each ray a page from history, each glimmer a memory carried across cosmic seas. The journey of light is also a journey of silence. Between stars, there is no air or wind, not sound or substance, only the thin breath of interstellar space. A few stray atoms float there, but for the most part, it is empty. Through this emptiness, photons move unbothered, unscattered. They carry no weight, yet they carry meaning. They carry the temperature of the star, the composition of its gases, the color of its flame. When scientists study starlight through prisms and instruments, they can decode these details. Within the thin rainbow of light lies knowledge. How hot the star is, what it is made of, how it moves. But to your eyes tonight, the photon brings something simpler, something purer, beauty. You picture this traveler of light passing other worlds on its way. It may have brushed near planets circling its star, worlds with oceans or deserts, or perhaps nothing but rock and dust. It may have crossed paths with comets, their tails glowing faintly. It may have slipped past other stars in the galaxy, unnoticed on its way toward you. Each step of its journey is vast, yet silent. The photon never slows, never tires, never stops, unless it meets an eye, a leaf, a stone, or the earth itself. Tonight it meets you. You let that truth sink in. Out of all the directions that photon could have gone, it arrived here, striking your eye at this precise moment. In some deep way, you are the end of its journey. You are the witness it has been waiting for, though without knowing. Its story is complete only because you saw it, because your mind shaped its arrival into meaning. There is comfort in this, the thought that the universe sends gifts without intention, that beauty can emerge from paths without design. You are here, and starlight is here, and together you share a quiet moment. The thought carries you deeper into stillness. You think of how fragile light seems, a flicker on your retina, and yet how persistent it is. No darkness in space could swallow it. No distance could diminish it. Light, once born, continues until it meets something. It is faithful to its path. Your breath slows as you let this quality seep into you. Like light, you too have traveled far to arrive at this moment. Your path has bent and shifted through the atmosphere of your life, yet something within you remains steady, continuing onward. Light's endless journey mirrors your own, and still questions rise gently, like ripples in water. If photons are born in the hearts of stars, and they travel so far, what does that say about the stars themselves? How do they sustain such light, such power, for so long? What happens when their fuel is gone, when fusion ends? Will their silence echo across the same distances, replacing the light we see now? For now, you do not need answers. It is enough to rest with the thought that every flicker of starlight is both fragile and infinite. You lie beneath a sky full of history, a sky full of arrivals, each one the end of a long, patient voyage. The shimmer you noticed before, the twinkle caused by air, feels different now. You know the story that lies behind it, the photon's long travel, its silence, its endurance. You see not just a flicker, but a messenger, trembling only in its final moments. As your eyes drift across the stars, you imagine them not as distant pinpricks, but as rivers of light still flowing toward you. Every night, the flow continues, unbroken, an endless current from the hearts of stars. You are afloat in that current, carried by its quiet song. And still, one thought lingers. If the atmosphere bends light into twinkling, and space carries it unchanged for millions of years, what is it, truly, that bends? What is light itself, this thing that travels, this thing that shimmers? Is it a wave or a particle or both at once? You let the question hang softly in the night air, leading you onward like a lantern in the dark. Above you, Earth's atmosphere is restless. Air ripples, waves of heat rise, and invisible currents shift. Just as water bends a stick placed inside it, the air bends starlight. The star itself is steady, but the air above you dances, making stars appear to twinkle. You are still lying beneath the quiet night, the stars above your head steady in their essence but shimmering in your sight. You know now that the light has traveled across an immense ocean of darkness, a journey so long and patient that it almost defies imagination. And yet, at the final moment, the last step of its voyage, the light begins to tremble, quivers not because the star is unsteady, but because the sky above you is alive. The atmosphere is your companion every moment of your life. You breathe it in with each inhale, though rarely do you feel its vastness. It stretches upward for hundreds of kilometers, a soft blanket encasing Earth. You cannot see it, yet you live within it. Tonight, as you gaze into the stars, you begin to sense its presence more clearly, not as an empty invisibility, but as a restless ocean of air. You imagine yourself floating within this ocean, suspended in currents that rise and fall. The air does not sit still. It moves constantly, stirred by temperature, by wind, by the rotation of the planet. Warm air rises from fields, from roads, from your own body heat, shimmering upward like invisible smoke. Cool air sinks, creating streams and eddies. Even on the calmest night, these tiny rivers of motion are everywhere, invisible but persistent. Light, so straight and faithful on its endless path, must pass through this ocean of movement. Just as water bends a stick when you place it in a pond, the shifting air bends starlight. Each layer of the atmosphere has a slightly different density, a slightly different temperature. These differences act like lenses stacked upon lenses, tilting the light one way, then another. By the time it reaches your eyes, the beam has wandered, giving the star a shimmer, a quiver, a living breath. You think of how familiar this is, though perhaps unnoticed until now. Have you ever looked down a road on a hot summer's day and seen the air ripple, making the distant view waver like a mirage? That same effect is happening here, not just across a road, but across the entire sky. The starlight becomes a dance upon the air, and your eyes are the audience to its performance. The sky above you is never the same from one moment to the next. Air currents shift, temperatures change, winds cross. In one instant, the star bends slightly to the left. In another, slightly upward. Your brain sees not the invisible motion of air, but the result. A star that twinkles, as though alive with its own pulse. This restlessness of the sky is sometimes called turbulence. It may sound like a harsh word, but in truth, it is a gentle kind of restlessness, a natural stirring of Earth's breath. Turbulence does not disrupt the stars themselves. It only shapes the way you perceive them, and in that shaping lies the beauty of twinkling. You begin to feel the sky differently. Instead of a static dome, it feels like something alive, something moving. You are not beneath a glass ceiling, but under a vast, breathing veil. The air around you is part of your life, part of every breath, and also part of the way you see the universe. In this way, the stars are connected to the very air in your lungs. Their twinkle is not separate from you. The same currents that bend their light also carry your breath, and also sway the leaves of trees nearby. You are woven into this same living motion. You close your eyes briefly and imagine watching a candle flame through rippling glass. The flame itself burns steadily, but what you see is a shimmer, a flutter, a flicker. The flame is unchanged. Only your view is altered. So it is with the stars. They are steady in their own distant brilliance, but through the glass of the atmosphere they appear to dance. When you open your eyes again, you notice that some stars twinkle more than others. The ones closer to the horizon shimmer furiously, flashing red, then blue, then white. The ones near the center of the sky are calmer, more composed, with only a faint tremble. You now understand why. Near the horizon, starlight must pass through a thicker layer of atmosphere, through more turbulence, through more shifting glass. By the time it reaches you, it has been bent many times, tossed about more roughly. Overhead, the path is shorter, the air thinner, and the bending gentler. Even within this difference, you find a kind of beauty. The horizon stars are dramatic, restless, full of motion. The stars overhead are serene, steady, quiet. Together, they give the sky variety, texture, and a rhythm that keeps your eyes moving. your thoughts drift to planets again. You notice how Jupiter or Venus, bright and steady, resist the twinkling. The reason, you recall, lies in size and distance. A star is so far away that its light comes to you as a perfect point, so tiny that every bend is visible. A planet, though still distant, is closer, and its disk covers a wider area in your vision. The atmosphere bends its light in many directions at once, and the effects average out, leaving you with a steadier glow. In this difference, you see how the breathing sky plays favorites, how its dance is more visible in stars than in planets. Astronomers, too, live within this breathing sky. They peer through telescopes, longing for steady images of distant worlds, yet always meeting the restless shimmer of Earth's atmosphere. For them, twinkling is both beautiful and troublesome. It blurs their view, distorts their measurements. They call this effect seeing, the quality of the night sky's steadiness. On nights when the air is calm and the turbulence gentle, the stars twinkle less, and their instruments can look deeper, sharper. On nights when the air is restless, the stars dance wildly, and their measurements blur. But for you tonight, without instruments, without urgency, twinkling is not a problem. It is a gift. The sky itself is performing, reminding you of its living presence. The air you breathe, the air that carries sound and scent and life, is also shaping the light of the universe. You imagine, for a moment, what it would be like to stand above this air, above the turbulence, where starlight would no longer twinkle. Astronauts orbiting Earth see the stars steady and sharp. Space telescopes like Hubble reveal the sky without the shimmer. The view is clearer, yes, but perhaps less intimate. From Earth, the twinkle makes the stars feel alive, connected to the same breath that moves across your skin. Without the atmosphere, the stars may be sharper, but they lose that flickering quality that makes them seem to watch, to whisper. The air is restless, yes, but in its restlessness lies connection. Just as your own breath rises and falls, just as your thoughts ripple and wander, the atmosphere stirs. You are not separate from this motion. You are part of it. The stars shimmer because Earth itself is alive. You take another slow breath, filling your lungs, feeling the air cool as it enters. You exhale, imagining the air rising, mixing, joining the currents above you. Perhaps, in some small way, the breath you release tonight will join the air that bends starlight for someone else tomorrow. In this way, even your breathing becomes part of the twinkling sky. The thought soothes you. The universe is not distant and separate. It is intimate, close, woven into every breath. You and the stars are joined by the same air, by the same currents of motion. Their light touches you only after passing through the veil you share. The stars above continue to flicker, each with its own rhythm. You begin to feel as though the entire sky is breathing, expanding and contracting in slow waves, like a great living chest rising and falling. The shimmer is its breath, a sign of life, and within that breath you too rise and fall, a smaller rhythm within the greater one. As you sink deeper into this stillness, a final thought emerges, soft, unhurried. If the air bends starlight in these ways, shaping your view, then what else can it reveal? Can this breathing sky, in its shimmering, tell you more about the colors of light, about the rainbow hidden within the flicker? You let the question rest gently in your mind, like a star waiting for its turn to shine. You explore how the atmosphere becomes a moving lens. Layers of air act like glass, but this glass is never still. Tiny differences in temperature and density make starlight wobble. In this gentle instability lies the secret of twinkling. You lie quietly, your body still, your breath slow. Above you, the night stretches wide, filled with countless points of light. Each star seems steady, eternal, unchanging in its brilliance. Yet, when you look closely, you notice the shimmer, the tiny, restless flickers that make the stars appear alive. The reason, you realize, does not lie within the stars themselves. It lies in the air that surrounds you. The Earth wears an invisible cloak. It is not made of fabric, but of gases, stretching hundreds of kilometers above the surface. This cloak is the atmosphere, and though it may feel transparent, it is far from empty. Like a river, it flows. Like a breathing creature, it shifts and sways. Tonight, this cloak becomes your focus. Imagine holding a piece of glass in your hand. When it is flat and smooth, you can see clearly through it. The world beyond remains sharp and undistorted. But if you tilt the glass, or if the surface ripples like water, the image bends and warps. The light no longer travels straight. The atmosphere works in much the same way. Each pocket of air is like a small, invisible lens, bending starlight this way and that. The bending of light has a name, refraction. You have seen it before, though perhaps you did not call it that. When you place a straw in a glass of water, the straw looks broken or bent at the water's surface. When sunlight passes through raindrops, it separates into the colors of a rainbow. In both cases, light changes direction as it moves from one medium to another, from air to water, from water back to air. The same rule applies in the sky above. But unlike a glass of still water, the air around Earth is restless. The atmosphere is layered, textured, filled with invisible differences. Warm air rises, cool air sinks, winds sweep across the land and sea. Each layer has a slightly different temperature, a slightly different density, and therefore a slightly different ability to bend light. Starlight, steady and straight as it enters Earth's atmosphere, meets these differences and bends again and again, like a traveler taking countless small detours on the way home. This constant bending is what gives stars their twinkle. The star itself is not flickering. It is not dimming and brightening on its own. Instead, its light is being jostled by the atmosphere, split and rejoined, redirected in ways too subtle for you to notice individually, but powerful enough to create the illusion of shimmer. You might picture it as if the air itself is breathing. Each inhale and exhale is invisible to your eyes, yet the stars respond, fluttering in sympathy. The night sky becomes not a painting of fixed lights, but a living dance between starlight and atmosphere. Now, imagine the air above you not as one smooth layer, but as many. Closest to Earth's surface lies the troposphere, the layer where weather lives. It is filled with turbulence, swirling currents of air heated by the sun during the day, cooled again at night. Above that lies the stratosphere, calmer, steadier, where the air is thin and the winds less chaotic. Beyond still lie higher layers, stretching to the edge of space. Together, these layers form the living lens that every starlight beam must pass through. It is this restless lens that makes stars appear to blink. Some nights, the twinkle is gentle, almost imperceptible. Other nights, when the air is unstable, the stars seem to quiver dramatically, flashing white, blue, and red as the atmosphere scatters their colors. The difference depends not on the stars, but on the condition of the lens. You may have noticed, too, that not every point of light twinkles. Planets, those bright wanderers like Venus, Jupiter, and Mars, often shine steadily, with little flicker. The reason lies once again in the lens of air. Stars are so far away that their light reaches you as a single, thin point. A small disturbance in the air can shift that point enough for your eyes to see it move. Planets, by contrast, are much closer. Their disks, though tiny, are larger in your vision. The same disturbances that jostle a star's light hardly change the appearance of a planet. It is as though a small ripple in a pond disturbs the reflection of a pinprick candle flame, but leaves the reflection of a wide lantern steady. This difference between twinkling stars and steady planets is a gift. For centuries, it has guided travelers across seas and deserts, helping them distinguish which lights belong to distant suns and which belong to worlds within our own solar system. The sky itself becomes a map, written in the language of shimmer. Think of the atmosphere again, not as something separate from you, but as something you are a part of. With each breath you take, you draw it in, and with each exhale, you release it again. The same air that carries oxygen into your body is the same air that bends starlight into your eyes. You and the stars are linked by this shared lens, woven together by the fabric of the atmosphere. If you close your eyes, you might imagine drifting upward, rising slowly through the layers of this lens. At first, you feel the warmth of the troposphere, where clouds drift like silent ships. You pass through breezes and thermals, through invisible swirls of heat rising from forests, fields, and seas. Higher still, the air grows thin. The turbulence quiets. The stratosphere is calm, the stars above more steady. As you rise further into the thin upper layers, the atmosphere fades into space itself. There, at last, the stars shine unblinking, their light sharp and unwavering, no longer bent by living air. Astronomers on Earth have long sought to escape the twinkle. For them, the shimmer is not beauty but blur, a distortion that hides the true sharpness of stars and galaxies. Telescopes on the ground must wrestle with the breathing atmosphere, their mirrors and lenses corrected by clever technology to counter the wobble of starlight. But above the atmosphere, in orbit, telescopes like Hubble look outward with perfect clarity. They see stars not as flickering points, but as steady beacons, each ray of light tracing a straight, unbroken line across space and time. Yet for you, lying quietly beneath the night, the twinkle is not an inconvenience. It is a lullaby, a gentle reminder that the sky is alive. The shimmer is not a flaw in your view, but a gift from Earth itself, a signature of the atmosphere that sustains you. Without this cloak of air, you could not breathe, could not live. And without it, the stars would not twinkle at all. The twinkle, then, is a kind of conversation. The stars send their steady light. The Earth answers, through its lens of air, by bending and shaping that light into something dynamic, something alive. When you watch the stars flicker, you are witnessing not just the stars, but the Earth's own breath, woven into the fabric of the universe. This idea brings comfort. The sky is not distant and cold, but intimate, connected. Each star you see is filtered through the same atmosphere that wraps around you like a blanket. You are not only beneath the stars, but within the same lens that carries their glow. Stay with that thought. The atmosphere as lens, as veil, as bridge. Without it, the stars would shine coldly, unwavering, sharp as crystal. With it, they shimmer softly, alive with motion, alive with Earth's breath. And yet, this lens is not permanent. As climate shifts, as temperatures rise and winds change, the atmosphere itself changes too. The twinkle of the stars becomes a subtle record of Earth's moods, a reflection of its restless balance. To watch the stars is to listen, quietly, to the breathing of the planet. You let this idea settle over you like a calm tide. The shimmer is not random. It carries the story of the air, the warmth rising from valleys, the cool breezes sweeping across oceans, the invisible patterns of a living world. You are watching not only the stars, but the Earth itself, written in light. And as you rest, you begin to wonder, if the air shapes what you see in the stars, what else does it shape? If this living lens transforms the light above, how does it shape the light below, the warmth of the sun, the colors of the sky at dawn and dusk? The thought lingers, soft and unresolved, like a question left gently on your pillow. Why do stars twinkle while planets shine steadily? The answer lies in distance, size, and perspective. A star is so far away that it appears as a single point. A planet, closer and wider, smooths out the shimmering. This chapter compares their quiet, different ways of shining. You lie quietly beneath the sky tonight, your breath steady, your body relaxed against the earth. Above you, stars glitter like scattered jewels, restless and flickering. Yet, as your eyes wander, you notice something subtle. A few of the brighter lights do not seem to tremble as much. They shine with a steadier glow, holding their ground while the others shimmer like candle flames in a breeze. These steady lights are planets. It is a small distinction, but once you notice it, you cannot unsee it. Some lights waver. Some lights hold firm. Both are beautiful, both ancient, both full of mystery. But they behave differently, and tonight you allow yourself to drift into the question, why? You know already that the air above you is alive with motion, bending and twisting starlight. That is what makes the stars appear to twinkle. Yet planets, even though they share the same sky, are not so easily disturbed. To understand this contrast, you must lean gently into the scale of distance and size. Imagine first the stars. Each one is unimaginably far away. Even the closest star, Proxima Centauri, is more than 4 light-years away. That means its light has crossed trillions upon trillions of kilometers, traveling through emptiness, straight and unwavering, for 4 entire years before touching your eyes. And most of the stars you see are far, far beyond that. At such distances, their immense size shrinks to a single pinprick. Through your naked eye, each star is no wider than a tiny point of light. A point so small that when Earth's atmosphere bends it even a little, you notice it. Every ripple of air, every shifting layer, makes that point dance and flicker. It is like looking at a candle flame from across a wide field, through the shimmering air of a hot summer day. The flame seems to tremble, not because the flame itself is unsteady, but because the air distorts it. Now shift your gaze to a planet. Planets are close, astronomically close. Venus, bright in the evening sky, may be only a few dozen million kilometers away. Mars, with its rusty glow, or Jupiter, glowing pale and golden, sit within your own solar system, not light years but light minutes from you. Their closeness gives them size. Though your eyes cannot resolve the disks of planets in detail without a telescope, they are not points. They are tiny disks of light, wider than stars appear. This difference matters. When the atmosphere bends and shifts the light of a planet, it bends one part slightly this way, another part slightly that way. But because the planet is seen as a small disk, not a single pinprick, the distortions blend together. They smooth out. One part may shimmer, another may not, and the result to your eyes is steadiness. The contrast is almost like listening to a choir instead of a single voice. A single voice wavers if the singer shakes, every tremor noticeable. But a choir, many voices at once, blends into harmony. Small shifts in one voice are balanced by others. Planets are like the choir, stars the lone singer. You can test this for yourself. On a clear night, notice the brightest object. If it shines steadily without much twinkling, it is very likely a planet. Venus, the evening star, is often so unwaveringly bright that it looks almost unreal, like a lantern hung low in the sky. Jupiter, too, with its pale golden glow, rarely twinkles. Saturn, slightly dimmer, still holds steadier than the stars around it. In contrast, Sirius, the brightest true star in the night sky, dazzles with constant twinkling. Near the horizon, its light may shimmer so dramatically it flashes in colors: blue, red, green, white. As the atmosphere splits and distorts its beam, it is no less beautiful, but it is less calm. You may notice, too, that the difference between stars and planets becomes clearer near the horizon. When you look low, through thicker layers of atmosphere, stars flicker wildly. Planets may still glow with steadiness. Higher in the sky, above thinner air, both twinkle less, yet the distinction remains. The planet continues to be the anchor, the steady lantern, while stars dance. Think of how reassuring this is. The planets, neighbors in your cosmic home, glow with calm persistence. They are close enough to steady you, to remind you that not all light is trembling. Stars, far away, carry the trembling voice of distance, of thinness, of being reduced to a single point. The difference is not only scientific but poetic. The nearby shines steady, the faraway flickers. In a sense, you are always looking at a kind of mirage. The sky you see is filtered by Earth's atmosphere, colored and shaped by air. Yet this mirage has rules, patterns, secrets you can learn. The twinkling itself becomes a guide. Astronomers through the centuries have used it, not as a nuisance, but as a way to know. A steady glow hints at a planet. A flicker points to a star. In fact, long before telescopes were invented, ancient skywatchers used this difference to separate planets from stars. The very word planet comes from a Greek root meaning wanderer, because planets move across the sky against the background of stars. But even without watching them move, the steady way they shine gave clues. They were lights of another kind, lights within your solar family, not distant suns. This gentle distinction still matters. When you step outside and look up, you are seeing not just beauty, but information carried in the way the sky behaves. Twinkling is not random decoration. It is a language. You are reading that language, perhaps without realizing it. Each time you notice the steadiness of Venus or the trembling of Sirius. There is a comfort in this. The sky above you is vast, but it is also knowable. Its lights tell their own stories. They reveal their distances and their natures simply by how they shimmer. The universe may seem overwhelming, but with patient eyes, you can begin to separate, to recognize, to understand. And still, the more you understand, the more mystery deepens. For even planets, steady as they seem, are not perfectly still. With the aid of a telescope, you see them shift, ripple, blur, as the atmosphere moves. Astronomers call this seeing the quality of the sky. On some nights, even planets appear to dance. Yet to your eye alone, they are calm enough to stand apart from the stars. Close your eyes for a moment and imagine the Earth's atmosphere again. A restless lens. Stars, distant and pointed, scatter and sparkle through its turbulence. Planets, close and wide, smooth out the tremors. Both are true, both are part of the same sky, both are gifts of perspective. When you open your eyes again, you may feel as though you are part of this balance, too. Sometimes your own thoughts feel like stars, flickering, restless, distant. Other times they feel like planets, steady, grounded, close at hand. Both belong in your inner night sky. Both deserve their place. You lie quietly, letting this awareness settle in you like a slow tide. Stars twinkle, planets glow. One does not erase the other. The sky is richer for their difference, and you are richer for noticing it. And as you let your eyes drift once more across the heavens, you may begin to wonder. If the air above you is what makes stars twinkle and planets steady, how do astronomers, with their telescopes, ever hope to see clearly at all? How do they look past the restless breathing of the sky? Astronomers call twinkling scintillation. The word itself feels like a soft spark in the dark, a shimmer caught between breath and silence. Here, you pause to reflect on how scientists measure and study this delicate trembling of light. Far from spoiling astronomy, twinkling becomes data, revealing the secrets of air, weather, and motion in the sky. You are lying on your back, the night cool and vast above you. A star glimmers faintly, then brightens, then flickers again, as though playing a secret game with your eyes. This dance, so familiar and yet so mysterious, has a name whispered gently through the halls of science: scintillation. The word itself feels almost like a lullaby, drawn from the Latin scintilla, meaning spark. A spark of light, a trembling flame, a reminder that what you see is both real and altered, both constant and transformed by the air you breathe. Scintillation is what scientists call the twinkling of stars. To you, it feels poetic, almost alive. To them, it is a phenomenon measurable, describable, and deeply informative. Every flicker, every shimmer, every pulse of brightness tells a story about the sky above you. The atmosphere is not still. It moves, it sways, it ripples. It bends light in tiny, ever-shifting ways, and the result is this restless sparkle. You see it as beauty. Scientists see it as both beauty and information. Close your eyes for a moment. Imagine a single beam of starlight traveling across millions of years. Through empty space, its path is straight and pure, untouched by anything at all. But when it arrives at Earth, the final thin veil of atmosphere changes everything. A patchwork of warm and cool air bends the light in many directions, scattering it in subtle ripples. When that beam reaches your eyes, it no longer seems steady. It dances, quivers, twinkles. This, in essence, is scintillation. Yet the science of it goes much deeper. Imagine the air above you as a flowing ocean. Waves of heat rise from rooftops and fields. Currents swirl invisibly between high and low pressure. These differences cause the air to refract, to bend, light slightly differently at every moment. To your eyes, the star jumps. To a telescope, the star smears. To an astronomer, it is a signal that the atmosphere is alive. You might think that twinkling would frustrate astronomers, and in many ways it does. When they gaze through telescopes, they want clarity, not wobbling light. Twinkling blurs images, softens edges, hides fine details. And yet, far from being only a nuisance, scintillation also provides clues. It tells scientists about turbulence, about the thickness of the atmosphere, about winds that cannot be seen otherwise. What to the poet is a mystery, to the scientist becomes a measurement. Consider how delicate the process is. To study scintillation, astronomers use tools that measure brightness over time. They record how a star's light changes from moment to moment, sometimes many times per second. The patterns reveal the scale of atmospheric turbulence. A slow, gentle twinkle may mean calm air. A rapid, jittery flicker may reveal strong winds high above. In this way, the twinkling sky becomes like a mirror, showing us the breadth of Earth itself. Pause for a moment. Imagine listening to the twinkle the way you might listen to rain. Drop after drop, soft and steady, each carrying information. If you had the ears of a scientist, you would hear the air singing through the shimmer of starlight. Astronomers sometimes compare the phenomenon to looking at a coin at the bottom of a swimming pool. The coin itself does not move, but as the water ripples, the coin seems to dance, bend, or break into pieces. The star above behaves the same. It is still, steady, unchanging in its brilliance. Yet to you it appears alive, restless, flickering. This illusion, caused by air and motion, is the science of scintillation. Even satellites have been used to study this trembling. By measuring how starlight changes at different points on Earth, scientists can build maps of turbulence. These maps guide observatories in choosing where to build telescopes. The clearest skies, the calmest air, are often found on mountaintops above much of the atmosphere's blur. That is why the great observatories rest on mountains in Hawaii, Chile, or the Canary Islands, where the stars can shine without as much flicker. But even there, twinkling never disappears completely. The atmosphere, after all, is alive, breathing always. And so astronomers have learned another way: adaptive optics. Imagine a telescope that can bend its mirrors in real time, correcting for the atmosphere's distortions. Like glasses for the eyes, these mirrors adjust hundreds of times per second. They cancel out much of the twinkle, restoring clarity. Without this, images of distant galaxies would blur. With it, we can see details so fine they once seemed impossible. Yet, in a gentle paradox, the very thing scientists strive to erase in order to see more clearly is also what teaches them so much about the air. By measuring scintillation, meteorologists can forecast turbulence. Pilots can understand where the sky may shake. Astronomers can choose when to observe, when to wait. Twinkling is not just beauty, it is knowledge. You may wonder, does scintillation happen only with stars? Not quite. Planets, being larger disks in the sky, twinkle far less. Their light, spread out, smooths over the turbulence. But in moments of strong atmospheric motion, even a planet can flicker faintly. The effect is weaker, less noticeable, but it too carries information. The distinction between the steady glow of planets and the shimmering sparkle of stars is one of perspective, distance, and size. Think, too, of how ancient people must have seen this trembling. Without words like scintillation, without telescopes or mathematics, they still saw the sky alive with flickers. They imagined stories, spirits, gods sending messages through the sparkle. In a way, they were not wrong. The stars do send messages, not from themselves, but from the air between us and them. To look at a twinkling star is to read a story written by the atmosphere. And so, as you lie beneath the night sky, you are both poet and scientist. You see shimmer and you can name it. Scintillation. You see beauty and you can measure it. The flicker of light becomes not only a wonder of vision but also a key to understanding the world above. Let your thoughts drift now to the precision involved. Instruments record changes of light faster than your eyes could ever follow. Computers model turbulence, revealing layers of air stacked like sheets of invisible glass. Each sheet bends light in a slightly different way. The patterns of twinkle become fingerprints of the sky. Scientists read them carefully, patiently, as though reading the pulse of the Earth. Even spacecraft sending signals back to Earth experience a kind of scintillation. Their radio waves pass through the atmosphere and flicker in much the same way starlight does. Engineers study these fluctuations to improve communication, to understand how storms in the ionosphere affect signals. Once again, what seems like interference becomes information. Isn't it calming to think of this? That even the flicker of a star, something so delicate and fragile, carries knowledge across distances? That the universe does not waste its whispers, but uses them to speak in subtle tones? Every twinkle you see is not only an invitation to wonder, but also a record, a quiet measurement written in light. Breathe deeply and imagine this knowledge as part of a continuum. From poets of the past who saw messages in the stars, to astronomers who now read turbulence in their flickers, the experience is the same. Wonder, followed by curiosity, followed by meaning. Scintillation bridges art and science, dream and data, vision and truth. As the night deepens, the stars continue their restless dance. You close your eyes, and the word lingers in your mind. Scintillation, a word soft as velvet, precise as glass. A phenomenon that belongs equally to the dreamer and the scientist. But even as you reflect on this trembling light, another question rises gently, like the moon over the horizon. What else does the air above us do to starlight, besides making it shimmer? What other secrets are carried in the quiet waves of light, distorted by our living sky? Sometimes stars appear to sparkle in red, blue, or green. The restless atmosphere bends each shade of light differently. Twinkling becomes not only a shimmer but a shifting rainbow. In these gentle flashes hides the story of color, energy, and distance. The sky whispers physics through its secret palette. When you step into the night and tilt your face upward, the sky does not present itself in silence. Even without sound, it speaks. Its language is not words but light. And not just plain light, but light that shimmers, bends, and reveals its hidden colors in the tiniest flickers. If you pause long enough, you may notice that some stars do not only twinkle but flash. Now a pale red, now a cool blue, and sometimes, for the briefest instant, a shade of green or gold. These colors are not painted by the stars themselves in their natural form, but by the atmosphere above you. The air becomes a translator, turning the steady glow of a star into a shifting spectrum, a subtle rainbow that arrives one heartbeat at a time. Light, after all, is not a single thing. It is a family of many shades, each one defined by its wavelength, each one carrying a slightly different rhythm of energy. Red light is the long, slow wave, like a calm breath stretched wide across the sea. Blue light is short and quick, like ripples on a restless pond. Green, yellow, and violet nestle between, each carrying its own pace, its own texture. As starlight passes through Earth's atmosphere, the air bends these colors unevenly. Just as a prism takes sunlight and separates it into a rainbow, so too does the atmosphere act as a living, moving prism, bending, splitting, and scattering the light. Unlike the neat rainbow cast through glass, however, the air is restless. Its layers tremble and shift. Heat rises from rooftops, winds stir invisible currents, and layers of different temperatures slide past one another. Each movement alters how the light bends. The result is a twinkling star that sometimes flashes not only in brightness but in color. You have seen this before, though perhaps you did not notice it. On a winter's night, when the air is especially unsteady, the bright star Sirius near the horizon becomes a jewel box of colors. One moment it burns red, then blue, then white again, like a diamond catching fire. Children sometimes mistake it for a flashing airplane, but it is the oldest kind of signal, light traveling across space, filtered by Earth's breathing sky. The physics behind this is gentle, though it can feel like poetry. Each color of light travels at its own pace through air, depending on the air's density and temperature. This difference in speed is called dispersion. It is dispersion that makes rainbows curve across the sky after a storm. It is dispersion that turns the edge of a soap bubble into swirls of shifting color. And it is dispersion that makes a twinkling star whisper to you in red, then in blue, then in green. If you hold the image softly in your mind, you might picture each starbeam as a bundle of threads. Some are long red threads, others short blue threads, others still green and gold. As they enter the atmosphere, the threads fray apart, tugged by invisible fingers of air. For a moment, one thread might shine brighter to your eye, then another takes its place. The weaving never stops, and what you perceive is a star alive with restless color. This rainbow-like effect is strongest when you look near the horizon. There, light must travel through more atmosphere before it reaches your eyes. Each additional layer adds more bending, more scattering, more chance for colors to split. That is why stars near the horizon shimmer more wildly, while those overhead appear steadier. You might notice that planets, especially bright ones like Venus or Jupiter, sometimes glow with a faint steady tint, yellow-white, perhaps tinged with gold. Their disks are wide enough that the color flashes even out, leaving only a gentle hue. But the stars, tiny and point-like, remain more vulnerable to the atmosphere's restless fingers. The color of starlight tells stories even beyond twinkling. In the laboratory of astronomy, scientists use a tool called a spectroscope, essentially a refined prism, to spread starlight into its rainbow and study it in detail. Within the rainbow lie fingerprints, dark lines where certain wavelengths are missing. Think of how much history is carried in those flickers. The light may have traveled hundreds, thousands, even millions of years before entering the air above you. It set out long before your lifetime, long before the birth of your ancestors, before civilizations rose and fell. For all that time, the light remained pure and unbroken, until, in its final moment, it touched Earth's atmosphere and fractured into shifting hues. The twinkling color you see is the last chapter of a very long story, a final translation before the light meets your eyes. There is something profoundly human in this. You too are shaped not only by your long journey but by the air you live within, the invisible atmosphere of your days, your emotions, your environment. Just as starlight reveals itself differently depending on the layers it crosses, so too do you reveal different colors of yourself as you move through life. You are not one note but many. You are not one constant shade but a spectrum. And just as the star is not truly flashing red, blue, and green, but only appears so because of the restless sky, you too might appear differently depending on the circumstances around you. Yet beneath it all, the star remains itself. Beneath it all, you remain yourself. The twinkling is not deception. It is truth made visible through interaction, truth revealed by environment. Sometimes, when the air is steady and clear, the stars above do not flash colors at all. They gleam white, sharp and calm. These nights are precious to astronomers, who need stillness to observe. But for the dreamer, the poet, the quiet wanderer of night, there is equal treasure in the colorful flicker. It is a reminder that the universe is alive, moving, restless even in its beauty. It is a reminder that even steadiness has its variations, that even constancy can contain change. Imagine for a moment that you could hear the colors as sound. Each wavelength would become a note. Red a low hum, blue a high chime, green somewhere in between. The twinkling of a star would then become a melody, a shifting song carried by the wind of the atmosphere. And if you listened closely, perhaps you could hear not just one star but the entire sky as a grand orchestra, each point of light shimmering with its own tone, together creating a cosmic music. Though your ears cannot catch this sound, your eyes perceive its essence. You are listening through sight. You are hearing through vision. The colors speak a language beyond words, a language that science measures but that your heart simply feels. And so, when you watch a star flicker from red to blue to green, you are not merely seeing a distraction or an illusion. You are witnessing physics perform its quiet dance. You are watching light interact with air, distance with atmosphere, energy with perception. You are participating in an ancient dialogue, one that began long before humans named it scintillation or dispersion, one that continues each night without pause. Take comfort in knowing that this language of colors is not reserved for scientists or poets alone. It is for you here and now, as you rest under the breathing sky. All you must do is look, soften your gaze, and allow the shifting hues to enter you like gentle waves. The science will always be there, solid and true. The wonder will always be there, fragile and alive. In the end, the colors of twinkling are not about stars alone. They are about connection. The star sends its light. The atmosphere bends it. Your eyes receive it. And in that triangle of distance, air, and perception, beauty is born. Without you, the final translation would not occur. The rainbow would not become real. You complete the story. So tonight, as the stars above shimmer with quiet fire, let yourself be the final witness, the final instrument that makes the sky's music audible. Feel the red, the blue, the green, not as flashes of physics but as whispers of the cosmos, speaking in its most delicate voice. And as you listen, let the thought linger. If light can speak in colors, if the air itself can paint with shifting hues, what other hidden languages might the universe still hold, waiting only for you to notice? And so, dear dreamer, our journey beneath the stars comes to a close. You've discovered why starlight seems to flicker, how our atmosphere bends and shapes their glow, and how science and wonder walk hand in hand across the night sky. But even now, the mystery lingers. Each twinkle is still a quiet reminder that the universe is never still. It is alive, moving, whispering through the very air we breathe. Tonight's answer opens only to deeper questions, and those questions will carry you gently into sleep or into the next chapter of curiosity. If this exploration brought you peace or sparked a thought you'd like to share, I warmly invite you to leave a comment below. I would love to hear what the stars mean to you. If you'd like others to find calm in science too, a simple like or share can help guide them here. And if you wish to return for more journeys, drifting between science and stillness, then subscribing will keep you close to our circle of curious minds. For now, let your eyes rest. Let the night sky remain with you, soft and steady. Until we meet again under the stars, may their quiet twinkle remind you that you, too, are part of this endless, glowing story.